What if the world you know, this earth beneath your feet, isn't the first version of itself? Not in the sense of dinosaurs or trilobites or mammoths, but in the sense of something more like us. Minds that wondered, hands that built, civilizations that perhaps rose and fell so long ago that even the rocks themselves struggle to remember. Before we let that thought unfurl, I'd like to ask you something simple. Where are you listening from tonight? What does the room around you feel like? Maybe it's quiet and dark, maybe it's a little noisy, maybe you're curled up with your phone or drifting in the soft glow of a laptop. Wherever you are, this is the moment we share together, one among millions of moments this planet has seen. And if you enjoy finding calm in questions that don't always have answers, I'd be grateful if you gave the video a like or even subscribed, because this little space of science and rest only grows when more people find it. Now, let's settle in. Because to imagine that Earth has hosted versions of itself before us is not just to look backwards, but to reconsider what it means to exist right now. The first thought people usually have when this question comes up is dinosaurs. They ruled for over 150 million years, longer than humans have existed by a factor so large it makes our own timeline look like a post-it note stuck on the side of a novel. But dinosaurs, as fascinating as they are, were not engineers. They didn't leave behind machines or cities or written languages. Their legacy is bones, footprints, and sometimes the delicate imprint of feathers pressed into stone. So when we ask whether Earth has hosted civilizations before us, we're really wondering about something entirely different, something that would leave behind artifacts of thought, not just of biology. It's an odd question because the evidence for us is everywhere. Plastic in the oceans, glass in the sand, steel buried in foundations, satellites orbiting overhead. If another species were to rise millions of years from now, they would almost certainly know we were here. Unless, of course, enough time passed for the Earth itself to do what it always does: recycle, erase, fold, and renew. Geology is not kind to memory. Sediments compress, tectonic plates swallow continents, oceans open and close. The very crust beneath our feet is not permanent, but a restless surface that hides as much as it reveals. That's what makes the question worth exploring. Could another civilization have existed so far back in time that the Earth has already forgotten it? This idea has a name in scientific circles, though it's usually posed half seriously. It's sometimes called the Silurian hypothesis, after a race of fictional reptilian people in British science fiction. A couple of actual scientists, Gavin Schmidt and Adam Frank, raised it not because they believed in ancient reptile civilizations, but because the thought experiment itself is valuable. If we wanted to find evidence of an industrial civilization that existed millions of years before us, what would we look for? What would survive? And just as importantly, what would not? The reality is that solid objects rarely last. Even something as massive as a skyscraper would be reduced to dust over geological time. The Empire State Building, left untended for tens of millions of years, would not stand proud. It would collapse, weather, rust, and eventually become indistinguishable from the sediments it sank into. Fossils of bones survive only under very specific conditions, and fossils of wood, fabric, or plastics are even more unlikely. But there are other kinds of traces. Chemical signatures in the atmosphere, layers in sediments that reveal unusual spikes of carbon, metals, or artificial isotopes. In fact, if you look at Earth's geological record, there are moments where these odd signatures do appear, though they usually have natural explanations like massive volcanic eruptions or asteroid impacts. But the possibility remains that such markers could also be the faint footprints of something else. When we look back, we don't see an unbroken history of Earth, but a patchwork quilt of fragments. Whole ages are missing, erased by erosion or tectonics. What we do know is that the Earth has been habitable for billions of years, and that complex life has existed for hundreds of millions. Within that span, there's plenty of room for rises and collapses we might never be able to detect. Even a civilization lasting for 100,000 years which would be unimaginably long by human standards, would still be a blink compared to the deep time of geology. Once erased, it might be gone completely, leaving only the faintest trace, if any. And this is where the question becomes more than just playful curiosity, because by asking whether there might have been civilizations before us, we also ask what traces we ourselves will leave. Will our plastics, our concrete, our isotopes mark a clear boundary layer for future geologists to find? Or will the churn of continents bury us so deeply that millions of years from now we too become a forgotten version of Earth? It's not about ghosts of the past so much as the fragility of the present. If Earth has hosted others before us, then we are just one more chapter in a very long book. And even if it hasn't, then we may be the only attempt so far, which makes our place in history both more special and more precarious. The thought doesn't have to be frightening, it can be grounding. Imagine the sheer span of time behind us, stretching into billions of years, and then realise that we're alive right now, in this particular blink. The air you breathe has circled this planet countless times. The atoms in your body have been recycled through stars, oceans, and living things long before you were born. To wonder whether there were others like us before is just another way of marvelling at how strange it is to be here at all. And with that, we can begin to follow the traces the Earth does keep. The rocks, the sediments, the cycles of creation and destruction that make up the story of this planet. Because if the Earth has hosted more than one version of itself, the only way we can know is by listening closely to what it still remembers. When you look at the ground beneath you, maybe a carpet, a floorboard, or a stretch of pavement outside your door, it's easy to forget that under all of it lies not just dirt and stone, but an archive. The Earth is a keeper of records, though not a very organised one. It buries, it shuffles, it erases, and sometimes it preserves. And every time we step outside, we're standing on a surface that has been many other surfaces before, each one part of a story that reaches back further than we can comfortably imagine. Geologists sometimes call the planet's crust a palimpsest. That's an old word for a piece of parchment that monks would scrape clean and reuse, writing new words over faint traces of the old. Earth does something similar. It lays down layers of sediments, lifts them up, erodes them away, and lays down new ones again. Each cycle adds a faint echo of what came before. Fossils, minerals, isotopes, trapped gases, even magnetic alignments that tell us which way the poles were pointing when that rock cooled. These are the whispers of the past, scattered and incomplete, but still there for anyone who knows how to listen. But here's the problem. The deeper you go, the less likely it is that those echoes remain intact. Rocks don't just sit still for millions of years. They melt, fold, grind, and slip under one another. Ocean floors dive into the mantle and resurface as mountains. The process we call plate tectonics is a kind of recycling program on a planetary scale. On average, the crust of the ocean floor is only about 200 million years old. To us that sounds ancient, but compared to the 4.5 billion years of Earth's history, it's just the latest chapter. That means if an industrial civilization had thrived 500 million years ago, much of the physical evidence would already have been swallowed into the depths and transformed into something unrecognizable. Still, not everything disappears. Fossils can last for astonishing spans of time under the right conditions. The trilobites that scuttled along seafloors over 500 million years ago still leave us their stony outlines. Entire forests have petrified into stone. Dinosaur bones, fragile in life, have become monuments of mineralization. Even delicate impressions like the feather of an Archaeopteryx or the ripple of an ancient tide can be preserved if the sediments were calm and the chemistry just right. That suggests that if there had been beings who built tools or machines, some trace might linger. Not the machines themselves, perhaps, but signs that something odd was happening in the environment around them. For example, consider carbon. We're leaving a sharp spike of carbon in the atmosphere and oceans, much of it tied to burning fossil fuels. It's likely that future geologists millions of years from now will be able to detect this as a distinct layer, a chemical fingerprint of our existence. If another civilization had burned fuels or reshaped their atmosphere, they too might have left behind such signatures. Similarly, we're producing artificial isotopes, radioactive elements from nuclear testing and reactors, that simply don't occur naturally in large amounts. If anything like that ever existed in the deep past, we might catch faint hints of it in the rocks. But here's where it gets tricky. Earth has had plenty of natural spikes and anomalies. Volcanic eruptions can flood the air with carbon and sulfur. Meteor impacts can scatter iridium across the globe. Rapid warming and cooling events have happened long before humans existed. The Permian extinction, about 252 million years ago, saw carbon levels soar and temperatures rise catastrophically. The reasons are still debated, but massive volcanic eruptions are the leading suspect. To us, that might look similar to the industrial footprint we're leaving now. If geologists in the future find a layer rich with anomalies, how will they decide whether it was nature or industry? Could some of the strange events in Earth's history already be the echoes of something more than geology? This is where the Silurian hypothesis becomes both fascinating and humbling. The scientists who proposed it weren't suggesting we have solid evidence of ancient civilizations. They were saying that our ability to find such evidence is limited, and that raises uncomfortable questions. If we disappeared tomorrow, how much of us would remain in 10 million years? 100 million? 500 million? Would anyone know we'd been here? Think of a modern city. Glass towers, asphalt roads, metal bridges. In a few centuries without maintenance, nature would reclaim them. Plants would split the pavement. Steel would rust into flakes. Concrete would crumble. Give it a few thousand years, and most of it would be buried under soil, rivers, or shifting sands. A few relics might survive in caves or deserts, but on a global scale the fingerprints would fade fast. In 10 million years, tectonics would have warped the land beyond recognition. Unless some traces made their way into stable sediments, it might be as if the city had never existed. Now extend that thought across millions of years more. How many versions of Earth might have risen and vanished, without a whisper loud enough to reach us? The rocks we study are filled with noise, and sorting the human-made from the natural is not straightforward. A sudden spike in temperature, a strange mix of elements, or even a mass extinction could look like the aftermath of industry. Or it could be the result of an asteroid strike. We tend to favour natural explanations because they require fewer assumptions. But the fact that we can even raise the possibility shows how faint the line is between what is natural and what is manufactured when you zoom out far enough in time. It makes you wonder about what counts as evidence. If an ancient civilization used biodegradable materials, little would remain. Even if they built with metals, most of those would corrode away. What if they lived in harmony with nature, altering ecosystems but leaving no skyscrapers behind? Would we even recognise their presence? Maybe what survives is not their cities, but subtle changes in sediment, odd mineral deposits, or unexplained isotopic ratios. In other words, maybe the echoes beneath our feet are already speaking, but we don't know the language. There's another challenge. Humans are biased towards seeing patterns. We want to find meaning, to connect dots, even when the connections are weak. That means we have to be careful not to see civilization where there is only geology. But the opposite bias also exists. Assuming that civilization is impossible in deep time simply because it seems too far-fetched. Balancing those two biases is hard. It requires curiosity paired with caution, imagination tempered with evidence. Still, even raising the question forces us to look at the ground differently. Walk across a rocky beach, and you might see pebbles, shells, seaweed. But to a geologist, those rocks are pages of a book, each with its own record of an environment, a climate, even a catastrophe. To wonder whether some of those pages hide the faint marks of another intelligence is to expand the story of Earth beyond just us. Maybe the echoes are faint because the planet itself insists on renewal. Or maybe they're faint because they were never there at all, and we are truly the first. Either way, the ground beneath our feet is never silent. It hums with memory, even if most of it is too quiet for us to hear. And as we listen for those echoes, we also hear ourselves, our footprints, our emissions, our structures, all layering into the record that future beings might study. The question of whether we are alone in Earth's history reflects back into the present. How loud do we want our echo to be, and how long do we want it to last? If Earth could speak, what would it say about everything it has seen? That question lingers when you look at a cliff face with its layers stacked like pages of a library. Some pages are thin, barely a whisper of sand or silt pressed into stone, while others are thick, coloured by iron, ash or ancient seas. Taken together, they form a memory far older than any human record. This is the planet that remembers, though it remembers in its own way, not like we do with stories and pictures, but with stone, minerals and chemical traces. Think about how fragile our own memories are. We forget names, we blur events. Sometimes we even remember things that didn't happen quite the way we think they did. Earth is no different. Its memory is imperfect. It records selectively. Some moments are preserved with striking clarity, like a fish caught mid-swim in the layers of shale, or a palm frond flattened so precisely you can count its veins. Other moments, entire ages are wiped clean, leaving only gaps. Yet even in its forgetfulness, Earth carries more than we often realise. For geologists, reading these memories is an act of patience. Every rock has a story, but not every story is easy to translate. Sandstone might speak of ancient rivers, limestone of shallow seas, coal of swampy forests compressed under pressure. Volcanic ash layers tell of eruptions that darken the skies. When you find a sudden boundary where one type of rock sharply changes to another, it can mean something dramatic happened. A flood, a climate shift, a mass extinction. In that sense, the planet remembers the same way scars remember an injury. The details may fade, but the mark remains. What's most fascinating is that Earth doesn't just remember biology, it remembers physics and chemistry. Inside its minerals are records of ancient atmospheres, tiny bubbles of air trapped for millions of years. Ice cores hold a timeline of temperatures, carbon dioxide levels, even volcanic eruptions written in layers of snow and dust. Magnetic minerals in lava align themselves with the Earth's magnetic field as they cool, freezing in place, a snapshot of which way north was at the time. Put all these pieces together and you begin to see Earth not just as a stage for life, but as a recorder of everything that's ever happened here. Now, the tricky part is that this memory isn't eternal. It fades, it erases, it overlaps. Imagine trying to reconstruct your childhood by finding scraps of old homework, broken toys, and photographs with corners missing. That's what science is doing with Earth's past. And in between those scraps are long stretches where we have no record at all. That's why the idea of earlier civilizations is both so compelling and so difficult. If they existed, would the planet's memory hold enough to tell us? Or would those traces be lost in the noise? Some of the clearest memories Earth has are the catastrophic ones. The asteroid impact that ended the reign of the dinosaurs, for example, left a worldwide layer rich in iridium, an element rare on Earth's surface but common in space rocks. That layer is like a bookmark in the story, instantly recognisable wherever it appears. Similarly, massive volcanic events leave behind thick deposits of basalt and chemical fingerprints that scream of fire and smoke. These stand out because they are global and abrupt. If a civilization caused planetary scale changes, we might expect to see something like that. A sudden spike in carbon, a thin layer of unusual materials, an anomaly in the chemistry of sediments. But here's a thought worth sitting with. We tend to think of civilizations in terms of grand monuments and machines, yet Earth doesn't remember in those terms. It doesn't care about buildings or languages. It remembers chemistry, pressure, temperature, magnetic fields. That means if we're looking for echoes of ancient intelligence, we shouldn't just look for artifacts. We should look for disturbances in the patterns Earth usually keeps. Something that doesn't fit the normal rhythm of volcanoes, meteors, or climate cycles. A strange scar in the geologic record that could suggest more than geology alone. Of course, the challenge is that nature is messy. It doesn't produce neat graphs or timelines. It leaves ambiguous signals. A sudden warming could be a greenhouse gas spike from industry, or it could be the natural outpouring of lava from deep within the crust. A thin layer of odd metals could be the residue of a mining culture, or it could be dust from a meteorite burning in the atmosphere. The planet remembers, but it doesn't annotate. There are no labels in the rock saying, "This was us." That ambiguity forces us to think about our own memory as a species. We build archives, libraries, digital storage. But how long will those last? Stone carvings can endure for thousands of years. Paper can last centuries if cared for. But hard drives, servers, and cloud data, those are fragile. If society were to vanish, our digital memory would fade shockingly fast. Within a century, most of it would be gone. Within 1,000 years, only fragments would remain. Within 1,000,000, almost nothing. Earth might remember us, but not in the way we hope. Not with our stories intact, but with traces of our impact embedded in stone. It raises a strange possibility. If there were civilizations before us, maybe they too had stories, histories, archives. Maybe they wrote books, etched symbols, stored data. But the planet doesn't preserve those kinds of memories very well. If anything remains, it would be subtle, a chemical anomaly, an odd mineral deposit, a thin scar in the record. In that sense, Earth's memory is more like a dream than a diary, vivid in some places, blurry in others, often frustratingly incomplete. And yet, for all its gaps, Earth remembers enough to give us perspective. It remembers 5 mass extinctions, each one reshaping life in ways almost unimaginable. It remembers climates far hotter and colder than today, seas that rose and fell, continents that collided and drifted apart. It remembers forests turning into coal, shells turning into limestone, mountains rising and wearing away, and through all of it, life has found a way to adapt, to continue, to return. That might be the most important lesson hidden in the planet's memory. Even if civilizations rise and fall, even if entire species vanish, the story goes on. Earth doesn't cling to one version of itself. It changes, renews, erases, and begins again. To wonder if others came before us is also to realize how temporary we might be, how easily our part of the story could become just another faded layer. But that doesn't make it meaningless. If anything, it makes the present more precious, because we are alive in one of the rare moments Earth has chosen to remember in such detail. And as we press our ears to the ground, so to speak, listening for those echoes, we also remind ourselves that we're shaping the memory Earth will keep of us. Whether it will be a scar, a whisper, or a clear and lasting mark is not yet decided. But the ground beneath us is already writing it down, layer by layer, grain by grain, patiently storing away the record of our age. If you stand in a museum and look at a fossil, maybe a towering dinosaur skeleton, or the delicate impression of a fern, it's easy to forget that the creature or the plant you're looking at once lived in a thriving world of its own. A world with its own climate, its own struggles, its own rhythms of life and death. That world is gone, erased by time, but its traces remind us of a simple truth. Earth does not move in straight lines. It moves in cycles. Periods of flourishing are followed by collapses. Creation and ruin take turns writing the script of history. We humans often think of history as progress, as a steady climb from caves to cities, from stone tools to satellites. But Earth's memory tells a different story. It tells us that nothing is steady for long. Whole ecosystems rise and fall. Entire families of animals dominate for millions of years and then vanish almost overnight. Each time, the loss feels total, yet life eventually returns. reshaped into something new. These cycles are not rare accidents. They are the rhythm of the planet. One of the clearest examples is the series of mass extinctions that punctuate Earth's history. There have been 5 major ones, and many smaller ones along the way. The Ordovician extinction wiped out most marine life around 443 million years ago, likely triggered by a sudden ice age followed by warming. The Devonian extinction came next, erasing many early fish and reef builders. The Permian extinction, sometimes called the Great Dying, was the worst of all, around 252 million years ago. Over 90% of species disappeared. Imagine almost everything alive today gone in a geological instant. Then came the Triassic extinction, clearing space for dinosaurs to take over, and finally the famous Cretaceous extinction 66 million years ago, when an asteroid ended the dinosaurs' long reign and opened the door for mammals to spread. Each of these events was catastrophic. Each marked the end of a world. And yet, in the ruins, creation followed. New species emerged, new ecosystems formed, new possibilities unfolded. That's the pattern. Destruction clears the stage, and life finds new scripts to perform. It's a harsh cycle, but also a creative one. Without the asteroid, there might be no humans. Without the Great Dying, the ancestors of dinosaurs might never have thrived. Without earlier extinctions, fish, plants, and mammals would not have spread the way they did. When you think about the possibility of civilizations before us, these cycles take on a different kind of weight. If intelligence arose once, might it have risen before, in some form we no longer see? And if it did, would ruin have swept it away just as easily as it swept away trilobites or dinosaurs? The cycle doesn't seem to care what it destroys. It is as merciless to intelligence as it is to coral reefs or ferns. If earlier civilizations existed, they too would have been at the mercy of these forces: asteroids, volcanoes, shifting climates, diseases, or their own mistakes. The cycle of creation and ruin doesn't only happen on grand scales. It happens in smaller ways too. Coral reefs grow, flourish, and collapse, sometimes over centuries, sometimes over millennia. Forests rise after glaciers retreat, only to be replaced by grasslands when the climate shifts. Rivers carve valleys, then change course and leave them dry. Even mountains, which seem eternal to us, are part of the cycle. They rise through tectonic pressure, only to be worn down grain by grain until they are plains once more. Nothing is spared. Nothing stands outside the rhythm. It's humbling to realise that even our own age, with all its technology, is just another point in that cycle. We are creating, yes, but we're also vulnerable to ruin. Climate change, resource use, nuclear risks, even cosmic accidents. All of these remind us that cycles continue whether we're ready or not. Our memory of history is too short to see how inevitable these shifts are. We imagine that cities will last forever, that nations and technologies will keep building upward. But Earth's story says otherwise. Every rise is temporary. Every flourish carries the seed of collapse. Yet the beauty of cycles is that they do not end with collapse. Out of ruin, there is renewal. The Permian extinction wiped the slate nearly clean, but from that devastation, the lineages that would become dinosaurs and mammals emerged. After the asteroid, mammals that had lived in the shadows of reptiles took the stage. Even the loss of ice sheets and the rise of deserts create opportunities for new life to adapt and expand. The end of one story is the beginning of another, though the characters change and the settings are unrecognisable. This brings us back to the question of versions of Earth. If the planet remembers cycles of creation and ruin so clearly in its rocks and fossils, then it's not impossible to imagine that intelligence could be part of those cycles too. Perhaps we are the first. Perhaps we are not. Either way, if civilizations rise in cycles, they would be bound by the same rules. They would flourish, leave their marks, and then vanish into the layers. The only difference is whether we, standing here now, can still hear their echoes. The cycles also remind us of scale. Our lifetimes are so short that we rarely feel the rhythm. A few decades, maybe a century, is almost of a sea. Even the span of human civilization, from early farming to the present, is only about 10,000 years, barely a tick on the clock of geological time. In that sense, we live in the stillness between beats, unaware of how loud the rhythm can be when it strikes. Extinctions feel distant, like stories from another world, but they are not distant to Earth. They are part of its breathing, part of its memory. There is something strangely comforting in this. Yes, the cycles are destructive, but they also show resilience. Life doesn't end. It changes. The planet doesn't give up. It adapts. Even if civilizations before us were erased, even if we too were someday erased, the Earth would continue to create again. The stage would not stay empty for long. Somewhere, somehow, new forms would rise. That is what the cycles guarantee. So as we wonder whether we're the first version of Earth or just the latest, the cycles whisper a reminder. Everything we build, everything we fear losing, is part of a larger rhythm. Creation and ruin are not enemies. They are partners. They shape one another, trading places over spans of time so vast we can barely comprehend them. And in their dance, life never truly stops. It just changes costume and begins another act. And here we are, standing in the middle of one act, uncertain how it will end, but aware now that endings are never as final as they seem. The ruins of today are the raw material of tomorrow. The cycle continues, and in that continuation lies both mystery and possibility. When people first hear the idea of forgotten civilizations, they often picture lost cities hidden under jungles, crumbling temples overtaken by vines, or perhaps ruins buried under sand, waiting for archaeologists with brushes and trowels to bring them back into the light. And in a sense, those kinds of forgotten places do exist. We've rediscovered whole societies that had slipped from memory. The Mayans, once thought to be scattered farmers until the jungle gave up the outlines of their great cities. The Indus Valley civilization, whose script still puzzles us. Göbekli Tepe in Turkey, thousands of years older than the pyramids, challenging our assumptions about when humans first built monumental structures. These are remarkable, but they are recent. They belong to the last 10,000 years, a blink compared to the age of Earth. The forgotten civilizations hypothesis asks something much bolder. What if the forgetting stretches not thousands of years, but millions? What if the Earth has already hosted civilizations before us, so long ago that their traces are gone or nearly gone? Not mythic Atlantis, but entire epochs of intelligent life erased by time, tectonics, and erosion. It is a question that borders on the fantastical, yet it's rooted in a real problem. Earth doesn't preserve evidence very well over deep time. The crust recycles, sediments erode, artifacts crumble. Even fossils, which feel so permanent to us in museums, are rare accidents of preservation. For every bone turned to stone, there are countless others lost forever. So what would it mean to take this hypothesis seriously? First, we would have to think about what kind of evidence could survive millions of years. A building? Unlikely. A road? Almost certainly not. A piece of pottery? Perhaps. But even pottery we make today erodes and shatters over just a few centuries when left exposed. Plastics might seem like durable markers, but in the long span of millions of years, even they would break down, perhaps leaving only a faint chemical signature in sediments. Metals corrode, glass weathers into grains. Nothing we make is immune to geological time. Instead, the best candidates for survival would be indirect. Chemical anomalies, isotopic oddities, sudden changes in the composition of rocks or sediments that can't be explained by natural processes alone. For example, if we disappeared tomorrow, future geologists might find a layer rich in carbon from fossil fuel burning, traces of radioactive isotopes from nuclear activity, and unusual concentrations of metals from our industry. These would be subtle, but detectable. If another civilization had once altered the Earth in similar ways, Those are the kinds of fingerprints we might still find. This is the essence of the Silurian hypothesis, a thought experiment proposed by two scientists not because they believed in ancient industrial civilizations, but because asking the question helps clarify how limited our own evidence would be if we vanished. Imagine a species 100 million years from now curious about us. What would they actually find? Maybe a thin layer of sediments showing a strange spike in carbon and plastics. Maybe traces of isotopes that don't occur naturally, but not much more. Our skyscrapers, our highways, our libraries, our digital clouds, all of it would be gone. That realization alone makes it harder to dismiss the possibility that others could have come before, erased just as thoroughly. Skeptics will point out quite reasonably that there is no evidence so far. Archaeology, paleontology, geology. None of these fields has uncovered anything that definitively points to pre-human civilizations. When odd artifacts do surface, they often turn out to be misidentified natural formations or more recent human creations, and absence of evidence is, as the saying goes, not evidence of absence. But the hypothesis is less about proving ancient civilizations existed, and more about recognizing how narrow our view of Earth's past really is. We are piecing together fragments from an enormous puzzle, most of which are missing. That leaves space for questions. It also forces us to think about what we mean by civilization. Our instinct is to imagine something like us. Cities, tools, art, machines. But what if intelligence took another path? What if it left marks that don't look familiar to us? Suppose a species developed complex societies, but worked with materials that decayed quickly, or built structures in ways that left no durable trace. Suppose their greatest achievements were biological rather than mechanical, altering life in ways we haven't yet recognized. Would we even know how to look for that? Then there's the matter of time itself. Civilizations don't need billions of years to vanish. Even 100,000 years, which is long by human standards, is a blink geologically. In that time, forests regrow, rivers shift, deserts advance, glaciers scrape the land clean, traces are buried or lost. If we imagine a civilization that lasted for tens of thousands of years, say 200 million years ago, what would remain today? Possibly nothing obvious, just a whisper in the rocks, if that. It's worth remembering that even our own record of ourselves is fragile. Most of human history is already lost. Oral traditions vanish when languages die. Wooden tools decay. Early settlements leave little behind once reclaimed by nature. Even in recorded history, vast archives have burned in wars, libraries have been destroyed, and knowledge has slipped through cracks. If that's true for just a few thousand years, the idea of losing millions of years of history becomes less absurd. This hypothesis also resonates with myths and stories. Many cultures have tales of worlds before this one, cycles of creation, floods, or fires that reset humanity. While we shouldn't confuse myth with geology, it is striking how often the theme of forgotten ages appears. Whether these are echoes of real events, like ancient floods remembered across generations, or simply metaphors for human fragility, they reflect a deep intuition that we may not be the first, and we may not be the last. Critics argue that extraordinary claims require extraordinary evidence, and so far we don't have that. They're right. But sometimes the absence of evidence highlights how poor we are at looking. We've barely scratched the surface of the ocean floor where sediments hold long histories. We've barely sampled the deepest layers of rock. We've only recently developed the tools to detect subtle, chemical, and isotopic signatures. Our search for past civilizations, if we ever take it seriously, has hardly begun. And even if the hypothesis is wrong, even if we are truly the first, the act of asking the question matters. It forces us to face the impermanence of our own achievements. It reminds us how fleeting civilizations are against the backdrop of geological time. It humbles us, showing that the planet's memory is vast but selective, and that we may be just as forgettable as any who might have come before. So the forgotten civilizations hypothesis is not really about proving that others lived here first. It's about perspective. It's about realizing that our dominance is not guaranteed, that our traces may be thinner than we imagine, that we're part of a cycle that may have played out before and may play out again. It is about seeing Earth not as a stage built for us, but as a restless recorder of countless acts, most of which it has already erased. And as we wonder whether civilizations before us were forgotten, we also wonder how we ourselves will be remembered, or if we too will become another layer in the silence of the rocks. The Silurian question has a curious origin. It doesn't come from geology textbooks or archaeological reports, but from science fiction. In the 1970s, a British television series called Doctor Who introduced reptilian beings called the Silurians, imagined as an ancient intelligent species that had evolved on Earth long before humans and then gone into hiding. The name stuck, not because scientists believed in reptilian overlords beneath the crust, but because it gave a convenient label to a thought experiment. Could there have been intelligent beings on Earth millions of years before us, erased so thoroughly that we have almost no chance of finding them? When Gavin Schmidt, a climate scientist at NASA, and Adam Frank, an astrophysicist, brought up the idea in a serious paper in 2018, they weren't suggesting that Doctor Who was right. They were asking what evidence an ancient industrial civilization, if it had existed, might leave in the geological record, and how we would recognise it. This became known as the Silurian hypothesis. The Silurian question, then, is the broader challenge it raises. Are we certain we're the first, or is it just that Earth has erased all evidence of any predecessors? It might sound fanciful, but the reasoning is sober. Human industry has already altered the planet in measurable ways. We've released vast amounts of carbon into the atmosphere, created synthetic chemicals that don't exist in nature, mined and redistributed rare metals, and generated radioactive isotopes through nuclear activity. These changes are leaving a geological signature. If another species studies Earth millions of years from now, they will find this signature in the rocks and sediments. Not skyscrapers or smartphones, but chemical oddities that wouldn't exist without us. So if there had been an earlier civilization, these are the kinds of traces we should look for, and the Silurian hypothesis asks us to consider whether such traces already exist in the record, but have been misinterpreted as natural events. Earth's history is filled with spikes and anomalies, sudden warming events, strange chemical layers, abrupt extinctions. Most of these are explained as volcanic outbursts, asteroid impacts, or shifts in ocean circulation. But the Silurian question lingers. How can we be sure they're natural and not the faint echoes of something else? One of the events that often comes up in this discussion is the Paleocene-Eocene thermal maximum, about 56 million years ago. During this period, global temperatures rose by as much as 8 degrees Celsius in a relatively short time, and carbon levels in the atmosphere spiked. The cause is thought to be massive releases of methane and carbon dioxide, possibly from volcanic activity or the destabilization of methane hydrates in the oceans. But if you didn't know better, the chemical signals look remarkably like the ones we're creating now. The Earth heated quickly, ecosystems were disrupted, and it took hundreds of thousands of years for conditions to stabilize again. Could this have been the footprint of an earlier civilization? Almost certainly not, but the fact that it can't be immediately dismissed is what makes the Silurian hypothesis interesting. Another piece of evidence sometimes discussed is the presence of unusual isotope ratios in sediments. Nuclear activity produces isotopes that don't occur in large amounts naturally. If a civilization had split atoms on an industrial scale millions of years ago, traces might still exist in sediments. So far, none have been found, but the search hasn't been systematic. The Silurian question encourages scientists to think about where and how to look. Ocean sediments are one promising place, since they build up steadily over millions of years and can capture chemical traces with remarkable precision. skeptics are quick to point out that extraordinary claims require extraordinary evidence, and so far the Silurian hypothesis hasn't provided any. There's no sign of fossilised cities, no advanced artefacts buried in ancient strata, no definitive chemical signals that can't be explained by natural causes. But the point isn't to prove there were ancient civilizations, it's to highlight how incomplete the geological record is, and how easily the signs of human activity could be erased over deep time. If we vanished tomorrow, in 10 million years the evidence of our existence would be reduced to a thin, ambiguous layer, easily misread as volcanic activity or some other natural event. The Silurian question also forces us to rethink what we mean by civilization. When we imagine predecessors, we tend to picture beings like us, tool users, builders of cities, masters of fire and metal. But intelligence could have taken other forms. Maybe it wasn't based on tools at all. Maybe it expressed itself through biological manipulation, altering ecosystems in ways we might not recognise as artificial. Maybe it rose in the oceans rather than on land, leaving behind chemical changes in marine sediments rather than stone ruins. We can't assume that intelligence always looks like us. What makes the Silurian question valuable is not that it suggests reptilian scientists once roamed the Earth, but that it broadens our imagination. It reminds us that our species occupies only the latest fraction of Earth's history. Complex life has existed for hundreds of millions of years. That's a long time for opportunities to come and go. If intelligence is possible, why should it have appeared only once? And if it appeared before, why should it have lasted any longer than we might? There's also a cosmic perspective. Astrobiologists, who study the possibility of life beyond Earth, often wonder how likely it is for civilizations to arise elsewhere. One of the puzzles they face is the Fermi paradox. If the universe is so vast and old, where is everyone? The Silurian question offers one possible clue. Maybe civilizations are common but fragile. Maybe they flare up, leave brief chemical signatures, and then vanish, their traces swallowed by planets that recycle themselves. If we can't even be sure whether Earth itself hosted others before us, how can we expect to find easy answers among the stars? Of course, the Silurian hypothesis hasn't convinced the scientific community that forgotten civilizations exist. Most researchers see it as a thought experiment rather than a claim, but that's what makes it valuable. It encourages scientists to test their assumptions, to refine their tools, and to think carefully about what kinds of evidence civilizations actually leave behind. It pushes us to recognize how much of Earth's history is invisible to us, and how easily we might be erased. The Silurian question, then, isn't really about reptiles from television. It's about humility. It asks us to admit that our knowledge of the past is incomplete, that our confidence in being the first may be misplaced, and that even if we are unique, we are not permanent. Earth has seen countless rises and falls, and whether or not they included civilizations, we're simply the latest expression of a planet that constantly reinvents itself. And as we think about those possibilities, we can't help but look forward as well as back. If another species one day wonders about us, what will they find? Will our chemical signature be obvious, or will it blend into the noise of natural cycles? Will our memory be erased, leaving them to ask the same questions we're asking now? The Silurian question is not just about what might have been. It's about what will remain of us when our time has passed. When we think about history, we often imagine it as a long shelf of books. Each volume holds a record of events, written down, preserved, waiting to be read. But Earth doesn't keep its past like a library. It keeps it like a chalkboard. It writes in stone, yes, but it also erases with the same hand that writes. Time, on this planet, is the great eraser. It leaves some things behind, but most are wiped away, smudged, or rewritten until the original markings are gone. This isn't just an idea. It's the reality of geology. Consider the continents we live on. The ground under your feet feels permanent, but it isn't. Tectonic plates are constantly moving, colliding, pulling apart and sliding past one another. Oceanic crust in particular is temporary. It forms at mid-ocean ridges, spreads outward, and eventually plunges back into the mantle at subduction zones. The average age of ocean floor is only about 200 million years. To us that sounds unimaginably old, but compared to the planet's 4.5 billion year history, it's like fresh paint. That means if a civilization once thrived on land that later sank beneath the sea, its traces would have been recycled long ago into magma, erased without a whisper. Even the continents, which are older and more stable, do not keep perfect records. Erosion wears them down. Rivers grind mountains into sand. Wind strips rock to dust. Glaciers scrape valleys clean. Layer upon layer is deposited, tilted, buried, folded, and sometimes melted entirely into new rock. In this restless cycle, most traces vanish. Fossils survive only under very specific conditions. Artifacts of wood, bone, or cloth almost never last more than a few thousand years unless they are buried in exceptionally dry or frozen environments. Metals corrode, plastics degrade, glass shatters, and weathers into grains. Over millions of years, even the strongest materials become unrecognizable. That is what makes deep time so humbling. We think of our world as full of monuments, technologies, and structures too massive to disappear. But time is patient. It doesn't need to knock things down all at once. It can wait. Given enough years, skyscrapers become rubble, rubble becomes sediment, and sediment becomes stone. In the end, the earth itself swallows what we leave behind. That is why we find so few traces of the creatures that lived before us. Not because they didn't exist, but because time has been busy erasing them. Even when traces do survive, they are rarely complete. Think about the dinosaurs. They lived for over 150 million years, spreading across the globe, filling every niche from tiny bird-like creatures to enormous sauropods longer than buses. And yet, our fossil record of them is spotty. We have bones here and there, tracks frozen in mud, feathers preserved in amber. But for all their dominance, what remains is a collection of fragments. Imagine trying to reconstruct human civilization in the distant future from a handful of crumbling skyscrapers and a few scattered tools. That's what paleontologists do every day, piecing together entire worlds from scraps that escaped the eraser. And if that is the case for creatures as massive and widespread as dinosaurs, what chance would a more delicate civilization have? If there were intelligent beings in the deep past, their record could be far thinner than that of animals who left behind bones and teeth. Civilizations build with intention, but intention doesn't guarantee permanence. Cities of steel and glass seem strong to us, but they are no match for the slow persistence of weather, water, and tectonics. Time does not need to hurry. It erases at its own pace. The Great Eraser doesn't just act on land. The oceans are perhaps the most thorough of all. Shipwrecks sink and scatter. Organic remains dissolve or are consumed. Sediments cover the rest. Within centuries, wooden ships vanish almost entirely. Even metal ships corrode to little more than shapes. If you stretch that timeline to millions of years, the ocean floor becomes as clean as a blackboard wiped down after class. Whatever had been there before is gone, unless it happens to be preserved in a stable, quiet layer of sediment. This is why the Silurian hypothesis strikes a chord. When scientists asked whether we could find traces of a civilization millions of years old, they weren't saying we should expect fossilized cities. They were admitting how thorough time's eraser can be. The odds of durable artifacts surviving long spans are slim. What we might detect instead are subtle chemical fingerprints, faint anomalies that survived where stone and steel could not. Even then, we can't be sure whether those anomalies point to life, industry, or simply nature itself. What's fascinating is how selective this eraser can be. It doesn't clear everything equally. Certain things survive better than others. Bones rich in minerals buried quickly can become fossils. Insects trapped in amber can endure for tens of millions of years in astonishing detail, right down to the veins of their wings. Footprints hardened in mud can outlast the animals that made them, but whole forests, whole cities, whole civilizations, unless preserved under the rarest of conditions, they dissolve into absence. This uneven record is why paleontology and archaeology require so much interpretation. We are not reading a complete story. We're reading whatever escaped the eraser, filling in gaps with careful inference, and sometimes we may be wrong. Sometimes what we call natural might once have been cultural, or vice versa. Time blurs the lines until certainty becomes elusive. For humans, this erasure has always been unsettling. We want permanence. We build monuments like the pyramids, the Great Wall, Stonehenge, not just for function but for memory. We carve names in stone to resist forgetting. Yet even these fade. Wind rounds the edges, rain wears down inscriptions, earthquakes topple walls. Given long enough, even the most ambitious structures will be dust. The eraser is impartial. It cares nothing for pride or glory. It works on kings and commoners alike, on skyscrapers and sandcastles without distinction. There is, however, a paradox in this. While time erases most things, it also highlights the few that remain. That is why fossils feel so precious, why ruins inspire awe, why fragments matter. They are survivors of erasure, small pieces of a larger story that once was. Their rarity makes them powerful. Each one is a reminder that the past was vast and lively, even if we can see only faint glimpses of it now. So when we ask whether earlier civilizations might have existed, we are really asking how much confidence we can have in the fragments that escaped. The answer, honestly, is not much. Our evidence is fragile, incomplete, and constantly at risk of vanishing further. Time's great eraser works slowly, but it never stops. What it leaves behind is chance more than intention. That means the absence of evidence is not always the evidence of absence. It may simply be the mark of an eraser doing its work too well, and yet this eraser has another side. It makes room for renewal. By clearing away the old, it allows the new to emerge. The forests that grow after glaciers retreat, the coral reefs that rise after seas shift, the civilizations that build on the ruins of others. All of these depend on erasure. Time clears the board so that life can write again. What feels like loss is also preparation. Without erasure, there would be no space for creation. Without ruin, no rebirth. In this way, the eraser is not cruel, just impartial. It ensures that nothing dominates forever, that change remains constant, that history never freezes. For us, it means accepting that we too will one day be erased. Our monuments, our cities, even our names will fade, but the world will continue, ready for whatever comes next. And in the faint memories the earth does keep, there will still be hints of us, not perfect, not complete, but enough to whisper that we were here for a while, before the eraser smoothed the page and the story moved on. When we think of the past, we tend to picture it written in stone, fossils pressed into rock, bones turned to minerals, layers of sediment stacked like dusty archives. But the air carries memories too, and sometimes those memories are even more revealing than the ground beneath our feet. The atmosphere is not just a space we move through, it is a record keeper, a chemical historian, and a silent witness to what life has done on this planet. If we want to know whether others came before us, one of the most important places to look is not beneath our feet but above our heads, in the thin shell of gases that surround the Earth. Air is a subtle medium, but it has an astonishing capacity to record change. Every time we burn fuel, we leave traces in the form of carbon dioxide. Every time a volcano erupts, it releases sulfur compounds that linger for years, sometimes decades, in ice layers or sediments. Even dust storms carry signatures, moving minerals from one continent to another, leaving clues about climate and ecology. Over millions of years, much of this information disappears, but some of it is preserved, frozen in ice, trapped in sediments, or absorbed into rocks. Scientists can read these clues like detectives following faint tracks across an ancient field. One of the clearest examples is the way ice cores preserve air bubbles. In Greenland and Antarctica, researchers drill deep into the ice, pulling out cylinders of frozen history. Each layer of ice corresponds to a snowfall, compacted year after year, century after century. Within those layers are tiny bubbles of atmosphere, perfectly sealed since the day they were trapped. By analysing them, scientists can measure carbon dioxide levels, methane concentrations, even traces of ancient volcanic eruptions. Some cores stretch back hundreds of thousands of years, giving us a remarkably detailed view of Earth's climate over that span. These records show us when ice ages began and ended, when carbon spiked, when temperatures rose or fell. They prove that air, for all its invisibility, remembers. If a civilization had altered the planet millions of years ago, perhaps it too left its mark in the atmosphere. Industrial activity changes air in ways that nature rarely does. The combustion of fossil fuels, for example, produces carbon with a distinct isotopic fingerprint. Plants prefer lighter isotopes of carbon, so fossil fuels, which come from ancient plants, are depleted in the heavier isotope carbon-13. When we burn them, the atmosphere's ratio of carbon-12 to carbon-13 shifts. Scientists today use this as proof that rising carbon dioxide is largely human-driven. If another civilization had done the same, even millions of years ago, it might have left a similar isotopic signal for us to find. There are other, even stranger, clues. Nuclear activity produces isotopes that are virtually absent in nature, like plutonium-244 or certain forms of uranium. Some of these isotopes have half-lives long enough that traces could persist in sediments for millions of years. Synthetic chemicals like chlorofluorocarbons, CFCs once used in refrigeration and aerosol sprays, also have no natural source. If we vanished tomorrow, these molecules would eventually break down, but they might leave chemical ghosts in soils and sediments. And if another civilization once altered their air with similarly unnatural compounds, hints might remain in the geochemical record. The problem is that air, unlike rock, is fleeting. It mixes, it disperses, it changes constantly. The atmosphere is restless. Storms churn it. Winds carry it around the globe. Over long spans of time, gases are absorbed into the ocean or fixed into minerals. What remains are only those traces that happen to be caught and preserved. That makes the search difficult, like trying to reconstruct a book when all you have are a handful of letters scattered in a bottle of water. Yet those letters are powerful, because they prove that even the invisible can leave lasting memories. One of the most dramatic atmospheric events in Earth's history was the Great Oxidation Event, about 2.4 billion years ago. Before that time, Earth's air was largely devoid of oxygen. Then, cyanobacteria, tiny organisms performing photosynthesis, began releasing oxygen as a byproduct. Over millions of years, this changed the atmosphere permanently, paving the way for complex life. We know this happened not because we were there, but because rocks from that time show sudden changes in their chemistry. Iron formations, sulfur isotopes, and other geochemical signatures reveal that oxygen surged and transformed the planet. In other words, life left fingerprints in the air, and the Earth kept them. That example matters because it shows how much impact biology can have on atmosphere, and how long those impacts can last. If microbes could alter the air so profoundly billions of years ago, is it really so impossible to imagine that an intelligent civilization might have done something similar much more recently? We're doing it now, after all, in ways that geologists of the far future will likely see as a sharp, unnatural spike. If Earth holds memories of oxygen from billions of years ago, then perhaps it could also hold memories of industrial activity from tens of millions of years ago, if it ever happened. But here lies the difficulty. Natural processes also leave strange atmospheric marks. Volcanoes can raise carbon levels dramatically. Methane can leak from clathrates on the seafloor. Even asteroid impacts can pump odd chemicals into the sky. To tell whether an anomaly in the air came from natural events or industrial ones, scientists need multiple lines of evidence. One signature alone is not enough. The challenge is distinguishing fingerprints in a world where nature often smudges and overlaps them. That is why the search for atmospheric clues is both fascinating and frustrating. We know the air carries history, but we also know how fragile that history is. We can see clear records in ice cores stretching back hundreds of thousands of years, but beyond that things get fuzzier. Sediments and rocks hold some of the older evidence, but it's fragmentary. If civilizations existed tens of millions of years ago, their atmospheric marks might be faint, buried, or lost entirely. The eraser of time works on air as much as it works on stone. Still, the possibility keeps the question alive. If air can remember oxygen from billions of years ago, it might remember industry from a forgotten age. If we know how to look, we might one day find anomalies that don't fit neatly into our catalogue of natural causes. And even if we never find such evidence, the act of searching gives us perspective. It reminds us that the air we breathe is not just for us. It is part of a story that has been unfolding since the beginning, carrying traces of every fire, every eruption, every breath that life has ever taken. And of course, it reminds us that we ourselves are writing in that story right now. Our cars, our factories, our power plants, our choices, all of them are leaving chemical words in the atmosphere, words that future beings may one day read. The air is recording us, just as it recorded volcanoes, microbes and glaciers. Whether we want it to or not, our age is being written into the thin blue film above our heads, waiting to be remembered, even as time works to blur the ink. If you want to find Earth's most patient archive, you don't look at mountains or deserts or even ice. You look at the oceans. Beneath those restless waves, in the quiet darkness of the seafloor, lies a library of mud and silt that has been collecting pages for millions upon millions of years. Each layer settles gently, one on top of another, trapping tiny fossils, grains of dust, chemical traces and fragments of the atmosphere. These sediments are messages in the deep, and they may be the best place to look if we ever hope to find evidence of forgotten chapters in the story of Earth. It's almost ironic. The surface of the ocean feels so empty, so transient, changing with every wind and tide. Yet the bottom is one of the few places where the planet's memory is steady and continuous. Year by year, century by century, sediments rain down. The skeletons of plankton, the dust of continents, the ashes of distant volcanoes, even the faint fallout of cosmic events. What seems like endless water is actually a vast conveyor belt of memory, writing slowly in mud. Scientists use drills mounted on research ships to extract cores from this archive. These cores are long cylinders of sediment, each one a timeline stretching back thousands, sometimes millions of years. By analysing the chemistry, fossils and isotopes within them, researchers can reconstruct ancient climates, ocean temperatures, and even the composition of the atmosphere. It's through these deep-sea records that we've learned about ice ages, warming events, and mass extinctions. They're fragile, but they hold details no stone or fossil on land could preserve. That makes the deep ocean an especially intriguing place for the Silurian hypothesis. If a civilization altered the planet millions of